today we're going to be talking about transformations with an emphasis on horizontal and vertical dilations. But what does a transformation do? Well, a transformation takes a function and it makes it wider or skinnier, moves it up or down, or it flips it over an axis, making it face upside down or face the other way that it was before. So an equation gives you context clues about what transformations it has based on where the numbers are and the function. First, there are numbers that tells you if the function shifts up or down or left to right. These are the k values, which is here, and the h value. So the k value is if a function moves up or down. And a positive k value means the function moves up. And a negative k value means the function goes down. So if it's like, if k is positive 1, the function moves up 1. If it's positive 2, up 2. If it's negative 2, down 2. Negative 1, down 1. Now what about h? H controls if a function goes left or right. And you can tell which value is k and which one is h because k is outside the parentheses, h is directly added to or subtracted from x. Now the difficult part about h is that it's the opposite of what you might think. So negative h actually moves the function to the right, even though it seems like it should be moving to the left because that's where the negative values are. So positive h is left. Again, so this is like, if it's like x minus 1, then that's 1 unit to the right, minus 2, 2 units to the right. If it's plus 1, it's 1 unit to the left, plus 2, 2 units to the left. Now, before I talk about dilations, there's one more thing, these negative signs here. So we'll talk more about what a and b values are, but if there's a negative sign in front of the a value, this means the function is flipped over the x-axis. So if the function looks like this, the function will then look like this. And if there's a negative value in front of the b value, then that flips it over the y-axis. So if the function looked like this at b, then it would look like this at negative b. Just the opposite, like the mirror opposite of what it was before. Now it's time to talk about dilations. Let's start with the a value, which is vertical. And it's a little hard to explain exactly what it does, so let's look at some examples. All right, so this is the regular parabola or the regular quadratic function y equals x squared. But what happens to the function if you change the a value and make it 1/2? Well, the vertex stays the same, and the function is still pointing up. It's going to infinity, not negative infinity. But what it does change is it gets wider. Okay, well, what about if you change the a value to 2? Again, the vertex stays the same, and it faces the same way as y equals x squared, but it gets skinnier. So from this, you can figure out when the a value is a fraction, the function gets wider. And when it's a whole number, it gets skinnier. And remember, if there's a negative sign, that just means it gets flipped over the x-axis. Now, when the function has a fraction as the a value and gets wider, this is called a vertical compression. And you can remember this because you can imagine smashing the function down vertically, like pressing from the vertex and from the top of the function and pressing it down. That would make the function wider, like compressing it. And when the function gets skinnier and there's a whole number as a value, that's called a vertical stretch. And you can remember that because if you stretch out from the vertex to the top of the function and stretch it out, the function would get skinnier. Now let's talk about the b value, which is horizontal. Again, we're going to look at a regular parabola and then what changing the b value does to the function. All right, so you know that this is a b value here because it is inside the parentheses and squared. The a value, there's only x is being squared, b value 1/2, and x is being squared. Same thing here. All right, so when the b value is a fraction, again, the function gets wider. And when it's a whole number, the function gets skinnier. So from this, we can say that b is a fraction, function is wider, whole number, so this is the same as vertical, but the names for this are different. When the function gets wider because the b value is a fraction, this is called a horizontal stretch, the opposite of when it was wider for vertical, which is a vertical compression. And you can imagine this because if you grab one side of the function and the other side of the function and you stretch it out horizontally, then it would get wider. Wider stretch for horizontal. And for the horizontal compression, it gets skinnier. And you can remember this because if you grab one side and the other side and push it together, compression and compress it together, it would get skinnier. This is a whole number, which is the opposite because when it got skinnier for vertical, that was called vertical stretch. All right, and those are dilations.